Hey, what is going on, guys? I'm Mario, and in this tutorial we're going to continue with our topology topic. So I got a question on how to model something like this using booleans, but since it's actually very connected to what we are talking about right now, I thought it would be interesting to create a video on it as well. So we do not actually need booleans for this detail. So let me just first break down again what we're going to do. So first we're going to create an object using only minimum number of polygons, points, and edges, just enough that we establish the shape. Then we're going to focus on equalizing the geometry side, meaning that we have even distribution of edges all across the model. Then the third, we're going to add supportive edges, and then finally we're going to make sure that we have a proper edge flow, and then finally also we're going to talk about thickness a bit. All right, so let's get started with this cylinder, and this time let's choose 28 sides, close, and then I'm gonna just scale this a bit, like so. And then let's rotate this under 90, like so. And then instead of using booleans, we're just gonna use the cut tool. So what we are doing is just creating this cut under an angle that we want, and then what we're going to do later is just use symmetry here, and symmetry is on x-axis here. So, and then we're just going to extrude, maybe one more, extrude this part and then even it out, and then we will get this same shape, but without using booleans. Now the only thing here I would like to do is just soften harden edges real quick, and also what we can do is now work on evening out our geometry like so, and maybe push this here. So to create the remaining geometry I would need to, I think, bridge here, or maybe even closer. So let's bridge this, and we can also bridge this as well. Just create a cut here in the middle and connect these 2 points. Also what we can do maybe is add one edge loop here, and let's add one here, and then we'll get this flow like that. All right, so this is, I think, good enough start, and I think we don't need this on the back. So we have just enough points and edges to get us started with our shapes. So the next thing that we would need to is even out the geometry. So let's add a couple of edge loops here and there so that we have more even spread, like so. All right, now that we have that, number 3 on our list is to add supportive edges wherever we can. And we need to add a support here. So we have a couple of problems, but not too big of a deal to fix. So let's just push this a bit here. And as you can notice here, we already have solution presenting to us. And what we need to do is just connect this to here. And also what we can do. And again, this is the same thing as I mentioned in last video, and also in the first video when we talked about topology, is how our flow would go depending on where you would stand, so where your head would point to. So I'll just also maybe push this here a bit, slide it so that we even it out a bit more, and then add one more here so that the sizes are more or less the same. And there we are. A few more fixes here. We will need to continue this to here and finish it right there. And yeah, so now we would have our surface, but without using booleans. One other thing here I would like to mention, because it's very similar to previous examples what we talked about, is that for now we cannot use edge flow like this, let's say. This is the edge flow that we covered up up until now, simply because we now removed that structural edge, so you would see how your flow would now go. And this is something that probably you would not want. So this is our structural edge at this point, so we cannot do much about it. So since we're now ready with the general shape, what we need to do as the last step is to add thickness. And there are a couple of ways that I like to approach using thickness. So obvious way is to add simply thickness by using extrude, but you will notice that you will have specific problem with overlapping edges that are very, very close. So one thing that I like to do when approaching extrusions is, or creating thickness, is removing the edges that are not necessary. So around this area. So for example, whatever is close and it's not close and not necessary, I would like to remove it, because then you will see that you will have less of that problem later. So let's maybe do a local translate on the inside, like so. And oops, what I wanted to do is select all faces and reverse, and then we'll have thickness like so. But you will notice anyway that on the inside we will have the similar benching style. And also what we would need is just to reorganize these edges a bit better so that they fit. And then what I would do is just, I would bring back the old edges that we had. But before I continue with this, let me just show you what sometimes I also like to do is I like to duplicate. So basically just clone it and scale until the thickness that I would like to have. And then we can scale it in this direction, like so. And there will also be a couple of fixes, but at least if you check inside, you will not have this pinching. And then what I would do is basically what we need to do here is just reverse the normals. And then what I would do is combine these two together so that we have one object. And then what I would do is bridge these together. Now again, we will have some sort of sorting out here. So for example, this edge will need to be a bit more down, so we can actually slide all these edges a bit down. Let's slide this first because we need the room. So here to here. Okay, if it's sliding not working, maybe we can just push it down a bit and maybe push it here a bit. And then this would be basically the result, that it would be a bit more cleaner on the inside. And the same thing then you would do on the outside. You would just bridge this together. So this is an alternative approach if you have a lot of connecting points, a lot of intersecting edges like we had in this case. So now the only thing is left is to add thickness to this area as well. So one way is you can add, let's say, 2 edge loops here. So when we subdivide, we have result that it's something like this. And now I'll turn, okay, so here also then we would need 1 loop to close this area. So yeah, this would be one way. I want to show you now what else you can do, but the results can vary depending on what you're trying to get. So you can also bevel this. Let me actually just slide this aside a bit. Bevel this. And as soon as we bevel it, I'm pretty sure that you will notice now what we have here. So what we have is now this type of flow. But also one other thing happened that is maybe something that we do not want. And if you check it a bit better, you will see that now this flow is actually interrupted. You see that it's flowing here inside. It's no longer a single straight line. So it will just depend what your result, what you would like to have as a result. And depending on the result that you need, then you will rearrange the flow. So in this case, I think that the previous one was working a bit better for us. And also here at the bottom, we can connect. But anyway, I just wanted to show you that not all flows are the same, and depending on what you need, you would need to play around with that. So okay, so here I need to connect these, and also okay, we can leave it, it's on the back, so it doesn't matter as much. And also what I noticed is that the other side something went off. So if you also have a problem where one side for some reason went fully symmetrical, you can always remove one side and then mirror it with merge vertices at the center, and there we are. So in any case, I just wanted to show a couple of more examples of different edge flows and what they do. So like in this case, in our case, it would be better that we just went with the one that we had before. And also here we can connect it like so, and here also we can connect it. For more, oops, okay, so I made an extra. Delete that as well. All right, so yeah, I hope that this made sort of a sense. So if we now go back, I'll just quickly undo this bevel thing and just go back to our original. Maybe I should have made a copy, but I think it should be fine. Okay, so to this point, so we would not need this edge. We would not need to bevel this, because in some cases only 2 edge loops will be enough. So there we are. And also if we would want, let me just quickly remove these 2, because we can slide this. We can slide this here just a bit closer so that we have a bit more sharper surface, and then just bring those 2 edges back and make sure that we have more or less an even distribution. And yeah, there we are. So 2 different edge flows, 2 different results. And again, that will always be a play to find out which edge flow works for which situation. But I hope that in general, the story here makes sense for you. So yeah, more or less, I think this would be it. So let me just maybe add one more edge loop here, rearrange a bit better. But as you can notice, it will just depend on the result that you want to have, and experiment a bit more with the edges and how the edge flow goes, and then you will compare the result, and you will see that maybe one result is better than the other, and you will then just go with that. It will just take practice, but in general, like I mentioned, I really hope that it all makes sense. In case you have any questions or examples to share, feel free to post them either in the comment section down below or in our Discord server. I'll be glad to help out if I can. And yeah, thank you for watching, and see you next time. Have a nice day. Cheers.